Have you heard of the Backstack? It stands for Backstage, ArgoCD, Crossplane, and Kyverno. I covered the first three in previous videos on this channel, so you can go back and take a look. In this video, I will give you a tutorial on the last tool in the stack, and that is Kyverno. In short, it is a native policy engine for Kubernetes. In this video, I will show you the top use cases and go through a demo of the tool. So stay tuned till the end to learn about all three use cases. Let's get started. Let's start with our Kyverno tutorial. For our agenda, we'll see what Kyverno is all about, the architecture, top use cases, including validation, mutation, generation, and we'll finish off with a demo. Kyverno is Greek for govern. It's a policy engine for Kubernetes. It's specifically built for Kubernetes. And the key features are policies as Kubernetes resources. You no longer need to learn a new language like Rego with OPA, for example. From a resource management perspective, you can validate, mutate, generate, or clean up resources, as we'll see later. From a security point of view, you can verify container images, inspect the metadata. When it comes to resource matching, you can use your label selectors and wildcards. It uses overlays for validation and mutation, similar to Kustomize. You can also use it for config synchronization across namespaces. It uses admission controllers. It can block non-conformant resources. It has different enforcement levels, so it can actually use policy violation reporting and report instead of just blocking. Kyverno also offers a CLI that can be used with CI/CD pipelines for policy testing. Now let's take a look at the architecture here. So as API requests come into Kubernetes, they follow this workflow at the top all the way until they are stored in the database at CD. So from HTTP handler, authentication, authorization, and then mutating admission, schema validation, and validating admission. The Kyverno model is that it actually interacts here at the mutating admission and validating admission. At these two stages, you can see at the bottom here, there's an admission review, and then the admission controller takes over. And all this is part of Kyverno's workflow. We won't get into the specifics here. You can also check that in the documentation. But just know that it interacts with the API calls at these two stages. And that's why it can do validation, it can do mutation and generation. And we'll see this in action. Let's take a look at the top use cases. The first one is validation. And this process categorizes your resources into two distinct outcomes. Compliant resources will receive an approval and proceed unhindered, while non-compliant resources are going to face a rejection and will not be admitted. Here's an example policy. You can see the API version. The kind is cluster policy. You can have a cluster policy that spans all namespaces, or if you just use policy, it'll only take effect within the namespace you're in. You give it a name, and spec validation failure action, in this case, is enforce. If you leave this empty, the default is audit, so it's not going to enforce anything in your policy. Then we have the rules themselves, and we can see that we have one rule. We give it a name called check team, and it matches on any resources of kinds pod. And there's a message that you can put out there validating, which is label team is required. And the pattern matching we can see here is we're looking for a label that has team in it. So basically, if we don't have this label of team, then the pod is not going to come up and you'll get an error message to that effect. The next use case is mutation. And mutation empowers Kyverno to dynamically alter resources before their admission to the cluster. This powerful feature allows for automatic modifications, enhancing resource configurations on the fly. And again, here's an example policy where we see the rule is applied to pods. And we have now mutate, patch strategic merge, metadata, and we're looking to add label of team Bravo. So here we're going to intercept a pod and we're going to add this label to it. Finally, the last use case we're going to talk about today is generation. And here Kyverno empowers users to dynamically create new Kubernetes resources by leveraging definitions embedded within policies. So our example here is we're going to see how we can leverage a registry credentials in a secret inside one namespace and clone it to another namespace. So in this case, we have the generate option at the bottom here, and we can see that we're generating a new secret, reg cred secret here, and we can see that it will generate this secret in any namespace that gets created. You can see we're cloning from the namespace Kyverno policies tests where our original secret lives, and we're going to clone it into any namespace, new namespace that gets created. Not only that, we're going to synchronize as well. So if you make changes inside the original namespace for that secret, it will get synchronized over to the new namespace that we created the secret in. I want to take a moment to thank UpCloud, the sponsor of this video. They have a great cloud offering. They've got 13 data centers across 4 continents with a strong presence in Europe, Asia, and the US. Developers love their high-performance servers and the easy-to-use self-service portal. Cloud servers start at 4.5 euros a month. And guess what? UpCloud doesn't charge for internet traffic, so no hidden fees for data transfer that includes outbound network transfer costs. 2 things I personally like about UpCloud. Number 1, they have a Terraform provider and even have a button to export what you've built outside of Terraform into your Terraform configuration. Number 2, they have a managed Kubernetes offering, so you can spin up a Kubernetes cluster right now and even test Kyverno on it. Sign up now with promo code TECHN850. You'll find the link in the description below, and you can get started with a 7-day trial and 50 euros free credits. Now let's take a look at a demo. In our demo, we're going to see how to install Kyverno, how to use validation, mutation, generation as our top 3 use cases that we talked about, and then cleanup and conclusion. So first things first, we want to install Kyverno, and you can install that using a Helm chart, which I've already done. So you can run Helm repo add, Helm repo update, Helm install, and notice that there is a Kyverno Helm chart, and they recommend to install this in its own namespace. In this case, we're creating a namespace called Kyverno, and this is the standalone installation for testing development. If you go to their website, there is one for high availability as well, which you would use for production installs. And then there is also the option to install some Kyverno policies. So now if I show you my Helm lists here, you can see we got 2 Helm charts. We got Kyverno and Kyverno policies. Okay, so those are already installed and ready to go. Now we're going to start off with validation, and we talked about what validation is. So we'll jump real quick into actually applying our validation policy. So let's go ahead and apply the validation policy that we saw in the slides. And we can check all available cluster policies with this command here, kubectl get cluster policy. You'll notice that we have more than the one we just installed because we had the optional ones that we installed earlier. So the require labels one is the one we just installed, and you can see that it has a validation action of enforce, whereas all the other ones that came out of the box are all audit. Now let's create a namespace to start testing our policies. So we'll call this namespace Kyverno policy tests, and we'll try creating a deployment without the required label. So we're going to run this here, and I'll show you what happens when you try to do that. You get this error message from the server when creating the no label deploy.yaml admission on webhook validate Kyverno service failed, denied the request. And you can see the deployment was blocked due to following policies. And here we've got the required label, autogen check team validation error, label team is required. Rule is autogen check team. And this is where it failed. So if we take a look at the files themselves, you can see our no label deploy. Here, this is a deployment, and down at the pod level, we see that there's an app nginx, but there's no label for our team. Okay, so that's why it failed. If we take a look at the policy itself, as you can see here, we are saying that for any pods, we need to have a label of team, as you can see here. So any kind of value for the label team. and we have a message that says label team is required. And that's what we actually saw. Label team is required right here. So now what we can do is deploy another deployment with a label that has team in it. So go ahead and deploy this one. So let's clear out of here and run this, and the deployment ran no problem. And if we take a look at this proper label deploy, you'll notice that at the bottom here, we have a team platform engineering that allowed us to deploy into Kubernetes. So if we move into our Kyverno policy tests namespace and run kubectl get all, you'll see our pod is running nicely here. Now, we can also take a look at our policy report by running this command kubectl get policy port. And here you can see that we have our pod, and you can see the Nginx deployment right here at the pod level, at the replica set, at the deployment. And what you could do is actually run a kubectl describe policy report and just grab a policy here. So let's do that. And what you'll notice is that we have a scope at the bottom, a summary for errors and passes. We've got 13 passes. And if you scroll up, you'll see all the different policies, and what was scored in this case is true. Severity is medium. The source is Kyverno. The rule itself, the result is pass. All right, so we can continue to look through here, but we're looking for the rule that we created, which is this one here, check team. You can see the result is pass. Policy require labels, check team, scored true. So you can go through the entire policy report and see everything with greater detail. Now let's take a look at mutation. So we'll take a look at this mutation policy.yaml, which we have here. And notice that it's similar to what we saw before, but this time we have the mutate option. And we're saying that we want to add this team Bravo. Now we have a redis.yaml. This is a very simple pod manifest here. And you can see that we don't have labels for this pod. So we'll see that we will get a label very shortly. So first things first, we need to apply the mutation policy itself. Then let's go ahead and deploy that Redis pod. And if we run kubectl get pod, this Redis pod, and show labels, notice now that our label is right there, team equals Bravo. So that got mutated in there, and we were able to see how we're able to put a label in a pod just by using Kyverno. Now let's try creating a pod that has an existing team label and see what happens. So we're going to create a new Redis pod with team equals alpha. Run that. And now let's see if a new label got created. And in fact, no, it didn't, because we already have team equals alpha here. So we didn't need to create another label. So that just showed us that it will only create labels for team if it does not exist. Now let's take a look at our last use case, which is generation, and take a look at this registry secret.yaml. Registry secret.yaml right here is just a simple secret that we have to access a registry for images. As you can see here, this is base 64 encoded. And then what we're going to do is apply this secret. Okay, and we have also a policy that we need to apply, and this is the registry secret policy, which looks like this. And here what we have is generate as the option, and we're generating a secret, as you can see here, for any namespace. We're going to synchronize, and we're going to clone a secret that we have in the Kyverno policy tests with the name regcred. So if I run kubectl get secret, you're going to see that regcred already got created in our Kyverno policy tests namespace. So this will get cloned over to any new namespace that we create. So let's go ahead and apply this policy. So we got to create a new namespace. We call it my test namespace. Let's go into my test namespace. Let's clear again. And here, let's go ahead and run get secret. And you see that the secret got cloned and copied over without us creating it in this new namespace. Because we generated a new namespace, we were able to see that Kyverno generated a new secret in that namespace based on the other secret that we had. And that's it. Now we can go ahead and clean up. You can just run these commands that will clean up everything for us. So we're deleting the namespace Kyverno policy tests. And we can also delete the namespace mytestns. And then finally, just delete the 3 policies that we created, one for validation, one for mutation, and one for generation. And that should take care of cleaning up everything. The actual Kyverno installation is still there. If you need to uninstall it, then you can reference the documentation that shows you exactly how to uninstall the Helm chart and any CRDs that got created as part of that Helm chart as well, because they might linger after you remove the Helm chart. So in conclusion, great job. You're able to learn a little bit about Kyverno's policy types, validation, mutation, generation. We saw a few examples, and this is really very helpful when you're running Kubernetes applications in production and you want to create some governance and make sure that you have the proper guardrails in your organization. Thanks for watching, and I'll see you in another video.